Okay, so the next section for trigonometry is to solve some trigonomic equations. And so, for example, and we looked at this a little bit in the last chapter, but you might have something like this. The sine of the angle is equal to, let's say, 3/5. This comes from a 3, 4, 5 right triangle. And so we could go through and we could find the value of all of the trig functions for this angle. And so we could find the sine of cosine of theta, for example, would be 4/5, or maybe negative 4/5, depending on where it is located, which is something we'll get into. But the question is, what is the actual angle? And some ways you could do it is you could construct using a pencil and a ruler and a protractor, a 3, 4, 5, and a compass right triangle. And then you could measure the angle with a protractor. And that seems pretty intensive work-wise, right, to accomplish. Another way you could do it is you could have access to what we did when I was learning back in the day, as I was getting to school by going through the snow, both ways uphill, or whatever that phrase is. And we had this table. And if we said for example, that's a bad example for this one, but for sine and cosine, but maybe I would have had one where I said the sine of theta is 1/5. And I want to find out what the angle is. And I would come down to sine, and I would start looking here, and I would try to find where is it the sine of the angle close to 0.2, and it's somewhere between 11 and 12 degrees. And that became how you would figure out, and there were some algorithms that we used to get a good estimate as to what the actual angle was and what we'd round to. But that is a very cumbersome way to do it. So luckily for you, your calculators have these tables built into them. And so we can solve this problem. Well, the way we solve it is similar to the way that we solve this problem. And I'll show you why and what I mean by that in a second. So if I've got 3n equals 9. Well, and I ask you, how do you solve this? First off, you'd probably tell me to divide both sides by 3. But then I would say, well, what's another way you could say that? And you would say, well, you could multiply by 1/3. And yes, the way that we like to think about this is multiplying by 1/3, because 1/3 is the reciprocal of 3. Which is also referred to as the multiplicative inverse. And the way that you solve equations in almost every other context is by doing an inverse operation. And so that's what we're going to be doing here when solving an equation like this, is we're going to be doing an inverse operation. Now, when we did that, another way of saying multiplying by 1/3 is 3 to the negative 1 power. And so essentially what happens is the rest of math adopts the notation of multiplication, which is the inverse operation is represented by this -1 as a superscript. I don't want to say exponent because it actually doesn't operate like an exponent except in the multiplication case. But we look at it like an exponent of -1. So the way we do that is we look at sine theta, and we say the inverse sine -1, of sine theta. So we take the inverse sine of one side, and then we take it of the other side as well. Well, just like 1/3 times 3 equals 1, sine, or equals n, sine inverse of sine theta just equals theta. And then we need to evaluate sine inverse of 3/5. Well, on your calculator, there is a button that says the sine inverse, and you do that by hitting the second button in the top left, the blue button, and then hitting sine, and you'll get a sine to the -1. And then you just type in 3/5, or 0.6, and you get 36.87. At this point, I should tell all of you, make sure that you're on your mode on your calculator, that you've switched it to degree. We're still working degrees. When we get to radians, we'll have to switch it back to radians. But again, for this problem, it's going to matter. And so the answer turns out to be 36.87 degrees. It's rounded to the nearest 100th. All right, so basically what you're going to do is you're going to be doing problems like this. But we need to also be thinking about the fact that the sine can be 3/5 in more than one place. And so it turns out there are more than just one answer to this equation. There actually is an infinite number of thetas that have the sine being 3/5. And that's because we have these reference angles. And if we just keep adding 360 each time, then if we know, like, so for example, since 36.87 works, if we add 360 to that, we get 396.87. And if you type in 396.87, to sine, you get, now since I rounded, it's not going to be exact, but it turns out to be 0.60000001, and so which is essentially 0.6, but when you get rid of the rounding that happened. And so there's this idea that it's infinite, but there's actually also usually going to be more than one inside from 0 to 360. So let's find the other one for sine, and this goes back to what we talked about with the positive and negatives. We know that sine is positive in the first quadrant, and so it's going to look like this. This angle here is 36.87. That's what we just found out. That's what sine of 3/5 would look like. And then also in the second quadrant, because we're looking at the y value, right? And so the y value is positive there. So this is going to be 36.87. So what's the other angle that makes this true? Well, it's the angle from here to here, which is 180 minus 36.87. So we do that on our calculator. And there actually does turn out to be two answers, 143.13 degrees and 36.87, and they give you the same thing. Again, you can put that into sine. Sine of 143.13 turns out to give you that 0.60000001429 value, exactly like we had before. Okay, so just to kind of look at a different example, we could have something like this. You want to find the tangent of theta. Actually, let's do cotangent of theta equals 2/3. Well, your calculator doesn't handle that. You can do them in your calculator. I think they're under math. But when you've got like a cotangent like this, you realize, well, cotangent is just actually equal to 1 over tangent of theta. It's just the reciprocal. So I can then do tangent of theta equals 3/2. So I do inverse tangent of both sides, which gives me theta equals the inverse tangent of 3/2. So I type that into my calculator, and I get 56.31. 56.31 degrees is what the inverse tangent of 3/2 equals, which is going to be what the cotangent. So the cotangent of 56.31 will equal 2/3. But we also have to think about is there another possibility from 0 to 360 that works? Well, yeah, again, you're talking reference angle. So 56.31 is right here. This is where 2/3 is positive. And then the other place it's positive is in the third quadrant, where this is 56.31. And so that gives you the tangent of theta, where theta is going to equal 56.31, but it could also equal 180 plus 56.31, which would be 236.31 degrees. And so there's two answers between 0 and 360. Now, sometimes you're going to be asked for what's the answer that is greater than 180, between 180 and 360. And so you would need to find the 56.31 first and then use it as a reference angle to find the 236.31. All right, one more example. This one's important. If you've got the tangent of theta is equal to a negative, let's just make something relatively easy, negative 1/2, for example. And so we do the inverse tangent of that. So you take the inverse tangent of negative 1/2. When we type that in, something interesting is going to happen. Because it's negative, you end up with a negative 26.57. And the reason your calculator does that is because if you remember, when we did the tangent of 90 degrees, we got undefined. And so the tangent function actually in your calculator is just going to be defined from negative 90 to 90, because there's values from all of those, not including 90 and negative 90, because those are undefined. But there's value in all of those. And so that's why your calculator gives you this negative answer as a degree. And so if the problem asks for 0 to 360, then you would need to realize, okay, that just gave me a reference angle. And so it is a reference angle of 26.57. Remember that just means when this is 1 and this is 2. It's in the fourth quadrant. Tangent is negative in the fourth quadrant, just like we showed. And so we need to find the values in the fourth quadrant, which is just going to be 360 minus 26.57. That's going to give you the angle from here all the way back around. And so that's going to give you, 333.43. And so that's one answer. But the other place that tangent is negative is in the second quadrant. And so we use a 26.57 reference angle here. So it just turns out to be 180 minus 26.57. So the other answer for this one is 180 minus that, which would be 153.43 degrees. So both of those work as answers. You can verify them if you type those into your calculator. So if I type in tangent of 333.43, I get negative 0.5. It's a little bit of rounding error involved. If I do the tangent of 153.43, same thing. I get negative 0.5001079712. And so I can verify that, yeah, those values give me a negative 1/2. There's some rounding involved if you didn't round your answers before you typed them in. If you just use the answer that it spit out as your reference angle, then it would get even closer to an answer.